Hey everyone, today we're going to be working on section 3.3, which is quadratic functions and their properties. So quadratic functions are one of our what's called polynomial functions, and polynomial functions are defined as f of x is equal to an times x to the n plus an minus 1 times x to the n minus 1 all the way down to a1x plus a sub 0. So this function is a function of x with a degree n, and we're going to be going through a number of functions of different degrees. Polynomial functions can be something as simple as f of x is equal to 4. So f of x is equal to 4 is our horizontal line, so this is a linear function. If we have a function of the first degree, it could be something like 3x plus 5. So our degree here on the first one is 0. Degree is 1. If we have a function like f of x is equal to 5x squared plus 2x plus 3, then n, our highest power of x, is equal to 2. This is the one that's a quadratic. And we'll be dealing with quadratic functions today. Now, polynomial functions can go as high as any degree. So you could have something like x to the 457th plus x to the 218th plus x to the 9th. And in that case, we'd have a degree 457. We, of course, will not be working that high in this course, but you will see some fifth degree polynomials and maybe even a little higher. Things that are not polynomials are a couple of things. So if you have a function with a fraction where x is in the denominator, that's not a polynomial function. So say I have x plus 1 over x squared minus 2x. So this is not a polynomial function. Any function that has a fractional exponent, not a polynomial function. So in polynomials, our exponents have to be non-negative integers. So you cannot have something like x to the 1/2 power. So that is not a polynomial function. That actually simplifies into the square root of x. So this is not polynomial again. Also, you can't have functions with x in the exponent position. So something like f of x is equal to 2 to the x, for example, is not a polynomial function. So these here are not polynomials and not what we will be dealing with today. So the definition of a quadratic function is when a, b, and c are real numbers and a is not equal to 0, the function ax squared plus bx plus c is a quadratic function. So it has a degree 2, and this a cannot equal 0 because if it did, then we're back to a linear function or a degree 1. The graph of a quadratic function is called a parabola. Always looks something like this or something like this. Each parabola opens always up or down. Later on this semester, we will work with some that aren't functions, and they open left or right, but these were restricted to functions, so they'll open up or down. The highest or lowest point of the parabola is called the vertex. Each parabola is symmetric with respect to a line that goes through the vertex, and this is called the axis of symmetry. Now, if I were to plot a graph just to show you what each of these things looks like, say we have a vertex here, and our parabola opens down. This red dot is the vertex. We could plot in our axis of symmetry. It would be a line like this. It's always equal to an x equals line because it's a vertical line. we will also locate any x-intercepts or y-intercept points. So to help us with some plotting of these graphs. Now the standard form of a quadratic is in this form. F of x is equal to a times x plus h squared plus k. This is in the standard form, and the vertex, if it's in standard form, is the point hk. So you can just take those coordinates right out of the standard form, and then you can plot the parabola that way. Now if it's positive, if a is positive here, then the parabola opens up. If a is negative, then the parabola opens down. So if I have a function f of x is equal to 3x squared plus 6x minus 2, I can plot that by putting it into standard form. In order to do this, we complete the square like we did for circles back in chapter 1. So f of x is equal to, I'm going to bring that 3 to the front, so x squared plus 2x. Then I'm going to leave a space for completing the square, and the constant is out in the back because I don't need it for my completing the square portion. So if I'm completing the square, remember that we take this middle term, we divide it by 2, and then we square it to get what we put in the back of this parenthesis. So here I get 1 on the inside, squared just gives me 1, so I'm adding 1. Now, when we were completing the square with 2 sides of an equation, whatever you add to one side, you also add to the other. When you're completing the square, when you only have one side of the equation, then whatever you add to one side, you also have to subtract from the end. So if I'm adding 1 here, be careful because what I'm actually adding is 3 to the equation because I have that 3 pulled out of the parenthesis. So I'm adding 3, which means that I have to also subtract 3. So factoring f of x is equal to 3. Remember this factors into whatever's in this parenthesis, minus 5. All right, so in my standard form, f of x is equal to 3 times x plus 1 squared minus 5. Now this h, negative, so we have a positive sign here, which means that my vertex, my hk, is -1, -5. All right, if I plot that on the graph, the point -1, we'll put 5, -5 is right here. And then my graph opens up because I have a 3 and it's positive on the outside. Now that 3 is pretty stretched, so if I want to get another point just to see where it is, I can get another point. The easiest point to get is your y-intercept point. So f of 0 to get the y-intercept. I can use this factored form or the form in standard. So 0 plus 1 squared minus 5. So we have, this is 1, 3, or -2. So here is a point. Because I am working with a parabola, anytime I get a point on one side, I can use the axis of symmetry to get a symmetric point on the other side of that axis. So I've got one here at 2, or -2. I'm going to also plot one here at -2. All right, this is a rough sketch, but it's right about there. Now we can form completing the square with any quadratic function in order to find the vertex. So if I were to, or if I want to try and do that, then follow the steps above. To complete the square. Minimum and maximum values of a quadratic function are the vertex of the function. So if I have something f of x is equal to ax squared plus bx plus c, the vertex in formula form is negative b over 2a for the x component, and then your function at negative b over 2a for your y component, so f of x. So this negative b over 2a, if you remember that part, then you plug your answer back into the equation. So if a is positive, what we get is a minimum value here. If a is negative, what we get is a maximum value. So a positive, then we have a minimum. Our vertex is at the bottom and the parabola opens up. If a is negative, we have a maximum. The vertex is at the top and the parabola opens down. So if I want to find the vertex and the axis of symmetry for a quadratic function, I can either use my use completing the square, or I can use that formula. So x is equal to negative b over 2a, and here a is equal to 2, b is equal to negative 3, c is equal to negative 5. You notice that this part doesn't have to do with c. If I'm writing them down, I write it down anyway, you use it later. So if I am plugging that in, x is equal to negative of negative 3 over 2 times 2. So we get 6. I'm sorry, we do not get 6. We get positive 3 over 4 for our x component. Now if I'm looking for the y component, then I'm going to plug that in. F of 3/4 is equal to 2 times 3/4 squared minus 3 times 3/4 minus 5. Squaring the 3/4, I get 2 times 9 over 16 minus 9 over 4 minus 5. Arithmetic, this will cancel and I get 8, so 9 over 8 minus, I'm going to put this in eighths, 18 over 8. And here I have, in eighths, we have 40 over 8. So 9 minus 18 gives me negative 9 minus 40 gives me negative 49 over 8 for my y. So my vertex is equal to 3/4 negative 49 over 8. Now the axis of symmetry, if you were thinking about it graphically, wherever you have your vertex, your axis of symmetry is the line that breaks it in half. So your axis of symmetry is always an x equals line, and it's the x equals the x coordinate of the vertex, so 3/4. That's my axis of symmetry. All right, moving to the next one, I have g of x is equal to negative 5x squared minus 4. So x is equal to negative b over 2a, and my a is negative 5, b is 0, there is no b term, c is negative 4. So x is equal to negative 0 over 2 times negative 5, and we get 0. Plugging in 0, so g of 0, negative 5 times 0 squared minus 4 is negative 4. So vertex is equal to 0, negative 4, which makes the axis of symmetry x is equal to 0. If I'm looking for the x-intercepts of a quadratic function, I can find those a number of two ways. I can either factor my function or I can use the quadratic equation or the quadratic formula. So either way, we're solving ax squared plus bx plus c is equal to 0. If you're using the quadratic, x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. If you don't have that memorized or you don't remember it from before, take a look on YouTube. There's they put it to a little song. It'll be stuck in your head forever. I'm very sorry, but you will know it. So take a look at that. Now, part of that form is called the discriminant. The discriminant gives you an easy way to determine whether you have any intercepts. So this thing is called the discriminant, negative or b squared minus 4ac. If it's greater than 0, then you have two x-intercepts. So if it's positive inside the square root, you have two x-intercepts. If it's equal to 0, you only have one. So the intercept falls actually as touching the x-axis. So inside the square root equals 0, then what happens is you have something that comes down and just touches the axis and goes back out. It could also come in from the bottom, touch the axis, and go back out. The first case is something that either starts below and opens up or starts above and opens down. So two distinct zeros. Now, if the inside is negative, the square root, then you don't have any x-intercepts. Visually, what that looks like is you have one that starts here and opens up, or it starts down on the bottom and opens down. So those are the three cases. So if I want to find the x-intercepts to this first quadratic function, I have 2x squared minus 3x minus 5. So 0 is equal to 2x squared minus 3x minus 5. That's the equation that I'm solving. So some practice on the using the quadratic equation or quadratic formula and this type of thing. A is equal to 2, B is equal to negative 3, C is equal to negative 5. So x is equal to negative b, so 3, plus and minus the square root of b squared, 9, minus 4 times 2 times negative 5, all over 2a, so 2 times 2. I have 3 plus and minus. This here gives me 40, so 4 times 2 is 8 times 5 is 40. Negative and negative means I'm positive, so 9 plus 40 gives me 49 over 4. Whoops. 9 plus 40 gives me 49 total. All right, 3 plus and minus. Square root of 49 is 7 over 4. So 3 plus 7 gives me 10 over 4. 3 minus 7, negative 4 over 4. So our zeros simplify to 5 halves and negative 1. Now, if I am asked for that in ordered pair form, then the answers are 5 halves and 0 and negative 1 and 0. When you're working on your homework or taking a quiz, make sure you're checking what form it's asking you for the response. If I want to find the x-intercepts of this next one, I have a equal to 2. B is negative 3. Oh, sorry, I'm looking at the last one. A here is equal to negative 5. B is equal to 0. C is equal to negative 4. So I'm solving this. This is equal to 0. I can either use the quadratic or I can solve this one a little more directly. So moving the 4 over, dividing by -5. If I were to take the square root of both sides, what happens is I have the square root of a negative number on my left-hand side. So I can't have a negative inside the square root, so I have no x-intercepts. If we were to graph these, this one here, it has a negative a term, and our vertex from it, scrolling back up, was the point 0, -4. So if I were to actually plot that in, the point 0, -4, right about here, and this negative sign for a means it opens down. So it opens like this. Versus my other one, our vertex on that one was the point 3/4 and -49/8. I'm going to change to blue. So we'll call that 1. So 3/4, -49/8 is a little more than 9. So we're right about here. And then it opens up because it's positive. So it crosses the axis at -1 and 5/2. Right about here. And looks something like this. Now, if I want to find the equation of a parabola given a point and a vertex, I can use this form of the function in order to find it. So f of x is equal to a times x minus h plus k. If I'm given the vertex of -3, -4, this is my hk point. So I can plug some of that in. So f of x is equal to a times x minus -3 plus k, so -4. So a times x plus 3 squared minus 4. And if we need to, what we are left with is we have not found this a term. So I do have a point that's on this equation though, or on this function, so I can plug that in for x and y. So this would be my x and my y. And plugging that in, I get 2 is equal to a times 1 plus 3 squared minus 4. Adding 4 to both sides, I get 6 a times 4 squared. And dividing through, 4 squared gives me 16, so I have 6 over 16 is equal to a. Simplifying that fraction, 3/8 is equal to a. Means my equation, f of x, is equal to 3/8 x plus 3 squared minus 4. All right, please let me know if you have any questions on this section. I do have office hours, and you can email me to meet at any time. Have a great day.